Hi, welcome back. We're going to look at chapter 1.3 of Chengal and Bolt's book, Thermodynamics. So there are certain terms that you need to actually memorize, understand and memorize, because these terms will be used throughout the lecture, throughout these 14 weeks of thermodynamics lecture. So we have the first one, system. A quantity of matter or a region is in space chosen for study. Okay, let's say an example. You are taking a potato. Just imagine a potato. Okay, or probably your body itself. You can take your body. Okay, so the surrounding will be surrounding of your body. So you have your body, right? This is you. Okay, what is surrounding? Surrounding is the area around your body. Okay, the example, if you're sitting on the chair now in your room, so the surrounding will be the chair, the room temperature, the room ambient of the room, and whatever that's around you. And what is the system that we are studying? The system that we are studying is you, your body. Okay, can you understand? Okay, next, boundary. So what is the boundary for you? Your boundary is skin, your skin. Your skin is your boundary. So in boundary, there is like two, which is one is fixed and one is movable. Okay, fixed boundary and movable boundary. So example, if you have a piston like this locked in a vessel, then this is a fixed boundary. Like for you, like in this piston which has moving boundary, this part is fixed. Yeah, this part, the side is fixed, but this portion is movable. So that is the boundary. Okay. Now system may be considered to be closed or open. So there is a difference between closed system and open system. Now answer this question. Is your body, if your boundary of your body is fixed or movable? Yeah, fixed or movable. If you're fat and you lose weight, it looks like it's movable also, isn't it? Yeah. So that is your body boundary, your skin. Okay, next let's move on to closed system and open system. So what's closed system? Closed system is controlled mass. A fixed amount of mass and there is no mass that cross the boundary. So you take a vessel, you fill up 10 kilogram of flour, okay, and then you keep it there. So this is a closed system, or the other name for closed system is controlled mass. This is very important terms, you need to memorize this, What is closed system? What is controlled mass? They will use it later, but if you do not know, then it's going to be trouble. Don't get confused, because we also have open system, which is called the control volume. Open system, it's called the control volume. So what is the difference between closed and open system? Okay, now I'm going to explain that shortly. So now open system is usually device like compressor, turbine, nozzle. We're going to look at this at chapter 5. And then both mass and energy that can cross the boundary, and a control volume. So this is a open system or control volume. Okay, the difference is when we have a closed system, you take a vessel, you fill up, and that's it, close. So what can go in and out of this vessel? Only energy can go in and out. Mass cannot go. Okay, whereas the open system, you have a vessel, okay, you fill up with things. It can have a continuous flow in and out. Mass can come in, mass can go out, energy can come in, energy can go out. So that is an open system. Okay, that's the difference. Okay, next we're going to look at this term, control surface. Okay, what is a control surface? Okay, the boundary of a control volume, it can be real or imaginary. Okay, example, a nozzle. Okay, in a nozzle, you know what's a nozzle, right? Okay, nozzle is example like, you have a hose, you have a garden hose, and then at the edge of the nozzle, you want to wash your car, you put in a nozzle. Why? Because you want to increase the speed of the water, right? So that is a nozzle. So the sides of the nozzle is a real boundary. Okay, of course, this area here, the one that I have highlighted, is actually open. Water can go in and go out, right? But then for thermodynamic purposes, what we do is that we imagine that there is a boundary. It's called the imaginary boundary. Just for calculation purposes, you draw this blue line. Okay. Otherwise, in real life, you do not have this such boundary here. If you have boundary, then how does the water go in and out, right? So this is the real boundary, and then this is the imaginary boundary. Once again, imaginary boundary is only for calculation purposes, for you to understand the calculation. Yeah, that's it. Yeah, in real life, the imaginary boundary is not even there. Okay, it's just for you to understand. Okay, so with that, these are the terms that you need to memorize. Yeah, bad news. Yeah, you need to memorize them. Yeah, no choice. Yeah. Okay, so we are done with control surface. Now we're going to go into properties of a system. This chapter 1.4 from your textbook. Yeah, so if you see, all this is covered. Yeah, you can just read up. Oh, sorry. You can just read up your textbook. Yeah, textbook's explanation is more elaborate. Yeah, you can just look at it compared to your lecture note. Okay, so we're going to go into 1.4, which is the properties of a system. Okay, so properties, any characteristics of a system. It can be pressure, temperature, volume, mass, anything. It can be intensive and or extensive. So what is the difference between intensive and extensive? So intensive, they are independent of mass. They don't bother. If you, let's say you have water, let's say the water's temperature is 25 degrees. Okay, water from the tap. So if let's say the pail can take up 5 kilogram, the temperature is still 25 degrees C. If the pail can take up 15 kilogram, the temperature is still 25 degrees C. So this is intensive property. Yeah, it doesn't depend on the mass. Example, temperature, pressure, and density. Yeah, of course, the density of water also doesn't change, isn't it? If 5 kilogram of water, the density is still the same. 15 kilogram, still the same. Okay. Now, whereas extensive property, they are dependent on mass. Yeah, they're dependent on the size or the extent. Okay, so that is the difference between intensive and extensive property. Okay, intensive and extensive. So what is extensive property? Volume. Yeah, volume, of course, volume. Okay, and then we have mass. Mass also is dependent on the size, right? Yeah, so that is the extensive property. Next, we have specific property. Okay, when you look at thermodynamics lesson, everything is actually in your textbook. Yeah, if you refer to your textbook page, yeah, you go to the table at the back of the textbook. Yeah, if you move on to the table at the back of textbook, like example in page 904. Yeah, 904. So if you go to page 905, you will see the steam table property. So if you see the steam table property, which is table A4, table A5, you will see saturated water table, yeah, temperature table. So look at the values in the table, yeah, specific volume, internal energy, enthalpy, and entropy. And if you see the values down there, the units down there, it's all divided by kilogram. Yeah, why is it divided by kilogram? And that is how thermodynamics, they actually report all the value in specific properties. Reason being, so that this table is actually universal. You can use the table for a case of 100 kilogram, or you can use this table for a case of 1 kilogram or 15 kilogram, whatever the mass is, you can still use, because you are dividing the value over mass. You are giving in specific value. Okay, so that's the reason why in thermodynamics the values are given in specific, but of course at the end of your working, you convert it to, you multiply with the mass, yeah, to get the actual volume or actual enthalpy or actual entropy, yeah, depending. Okay, now next I'm going to move on to the theory of continuum. This is also from your textbook, yeah, theory of continuum. Okay, what is this theory of continuum? Yeah, so let's read up. Matter is made up of atoms that are widely spaced in gas phase. Yet it is very convenient to disregard the atomic nature of the substance and view it as a continuous homogeneous matter with no holes, that is the continuum. Okay, I give an example. In solid phase, all your molecules are arranged side by side, correct? So if this fella is heated up, the next one will start vibrating and the heat is being transferred. There is no holes in between, right? Okay, we assume that it's perfectly being transferred. Whereas in water, there is a gap. And for gas, the gap is even bigger. So in thermodynamics, what we do is that we say that there is no what you call no gap. There is nothing here, like as if the molecules are actually side by side. Yeah, they are side by side like the solid phase. Yeah, so which means if there is a heat transfer or there is energy transfer, it is transferred as if it's transferred like in the solid phase. Okay, so that is the continuum theory, where we assume that there is no gap between the molecules. There is no gap between the molecules. Okay, so I hope you understand that. Okay, next would be density and specific gravity. You're familiar with density. Density is mass over volume. The unit is kilogram over meter cube. Whereas the specific volume probably is something new to you. Yeah, specific volume is actually your volume divided by mass. Or in another word, it is actually the reverse. Yeah, the reverse of density. The reverse of density. Can you see? That's the specific volume. Now, what is specific gravity? Specific gravity is any density as long as it's divided by the density of water. Density of water is taken as standard. They are 4 degrees, which is 1000. Okay, so that is the density of water. Now, why do you give report in specific gravity? There must be a reason, isn't it, for reporting it in specific gravity. Okay, reason being so that the comparison can be done. Okay, so the standard is 1. So when you have 1.05, what does it tell you? It means the blood is slightly denser than water. Okay, now let's look at mercury, 13.6. It is so much denser than the water. Okay, so which means if I put water and if I drop mercury, the mercury will sink down here. Okay, you get it or not? Yeah, that's the meaning. Yeah, that is the meaning. And if you see gasoline, 0.7. So if gasoline, it's going to be floating up here. Okay, so that's why it is all given in specific gravity. Yeah, so that you can compare. Okay, now let's look at ice. Wow, 0.92. What does it mean? Yeah, God is always great. So God has created that the ice, which is from water but in solid phase, actually has a specific gravity of 0.92. So which means if you have water, if you drop an ice, the ice will be floating. Yeah, the ice will be floating. Yeah, so like this. Yeah, my drawing is not too accurate, but this is how it is. So ice will be floating. 90%, oopsie. Okay, 90% of the ice is actually in the water, submerged in the water, whereas 10% will be floating up. Okay, that's the 0.92 meaning. Yeah, why does God create ice to be less denser than water? Because for aquatic life, if ice floats, then the fish and all the other aquatic life can actually live below the ice, even though if it's in winter or in North Pole or South Pole. Yeah, and then it also becomes like a heat repellent. Yeah, okay, so that is the specific gravity of ice. Okay, so I hope you can understand all this. Yeah, so we're going to move on to specific weight. I forgot to cover this. So specific weight will be, you know what's weight, right? mg, right? Which is given by Newton divided by unit volume of a substance. So that is your specific weight. Okay, given by unit Newton meter cube. Okay, so next we're going to move on to state of equilibrium. State and equilibrium. So these are things, these are again some terminologies that you need to memorize. Yeah, so what does it mean by equilibrium? Equilibrium is a state of balance. Example, like you now sitting in the room, right? If you are too warm, what do? You fan yourself, and then you on the aircon, you on the fan. You are trying to attain a state of balance, attain a state that you will be very comfortable with. Yeah, so when you attain a state that you're comfortable with, you will stay focused. You will not be distracted by fanning yourself or finding for the aircon remote control and all. Yeah, example. And if you are too cold, what do? You put on jacket, you put on whatever to make yourself back to state of equilibrium. Yeah, so anything that is not in equilibrium will try to find, will have a driving force here to make sure that the process goes back to the equilibrium state. Okay, so there are few terms here. We have thermal equilibrium, mechanical equilibrium, phase equilibrium, and chemical equilibrium. Thermal equilibrium, if the temperature becomes same throughout. Okay, I give an example. Let's say if you have a cold water and then you add on with a water which is 40 degrees, and then you add on another cup of water which is 30 degrees, and your ambient room temperature is 20. What happens? At the end of the day, it will actually stabilize and get to 32 degrees. So this is a thermal equilibrium. Whereas mechanical equilibrium involves with pressure. If you put anything that is very high pressure in a literally a normal atmospheric pressure, the high pressure will find its balance, and everything will attain atmospheric pressure. If it's at the ground level, yeah, if you climb up Mount Everest, then it's going to be different. The pressure will be dropping. Next, we have phase equilibrium. So if you have two phases, example liquid phase and gas phase, you put in together, they will also find phase equilibrium. And then we have the chemical equilibrium. This one you have studied in chemistry, right? So it will go to a reaction, and then at the end of the day, it will be equal, right? The reaction of on the left side with the on the right side. Yeah, so this is chemical equilibrium. Okay, so the state postulate. What is a state postulate? State postulate is like what do you call, it's a state of simple compressible system is completely specified by two independent and intensive properties. It's like a you are explaining, you are explaining the situation. Okay, let's say example, we have this example here. Okay, we have a piston. So now I'm going to talk about this piston. I'm going to describe this piston. Okay, this piston has nitrogen inside. The temperature is 25. The specific volume is 0.9. Example like you. If you want to have a girlfriend, you will have an imagination, or you will say, okay, I want my girlfriend to be like this, like this, like this. You have criteria, right? So likewise, in a state postulate, it is the criteria that we are actually describing about a system. Okay, only when you describe, you will know what is this, isn't it? Yeah. Like example, what is it filled up with nitrogen, or with what temperature, what pressure, what is the mass, example, you describe. Yeah, that is a state postulate. Okay, so next we will move on to another terminology, which is the last subchapter of this video, which is 1.7, process and cycles. Okay, this is again something that you need to memorize, you need to understand, really understand. Yeah, otherwise you will find it very difficult in the next coming lectures. Yeah, okay, pay attention. We have process. So process is any change the system undergoes from one equilibrium state to the other. Okay, path, the series of states through which the system passes through during a process. Example, can you see state 1, state 2? So this is the process path. For the system to achieve from state 1, situation 1, with the property of A and property of B. So this can be temperature and pressure, any property, yeah. Okay, to the next situation, next state. Okay, so it undergoes a process path. Okay, like example for you, like example at home, you are coming to Sunway College. Okay, you start from your home. Yeah, you start from your home. Okay, and then you come to Sunway College, right? State 2 example. You take path, process path. Some of you take CASAS, some of you may take Federal Highway, some of you may take maybe NPE. But at the end of the day, yeah, you reach Sunway University using whatever path that is suitable for you. Okay, it can be anything, any path, path 1, path 2, path 3, path 4, as long as you achieve to reach Sunway University. So yeah, so this is the just a simple way of understanding the state, and state 1 and state 2 and the process path. Okay, so in thermodynamics you must have property, otherwise it's difficult. Like in this case, you have property A, particular temperature, lower temperature than state 2, pressure, lower pressure than state 2, or maybe this is volume. State 1 volume is lesser than state 2, example. Yeah, okay. So let me just move on to the next one, which is quasi-static or quasi-equilibrium process. A process that undergoes really very slow and steady, extremely very slow and steady. Why? So that it doesn't break or it doesn't rupture. Okay, example in your real life. I give you another example in your real life. Okay, you like a girl. If those who are listening here, if you're a boy, you like a girl. If a girl, you like a boy lah. Okay, whatever. So I'll just take an example. Like you, a male, you tend to like a girl. You have a crush on this girl. Okay, so you really like this girl. You go to the girl, you cannot go and tell her immediately, I love you, I want to marry you, right? The girl will have a heart attack and she may just collapse there itself. Or she may just give you a thigh slap. Yeah. So what do? Slowly, day by day, you get closer to her. Day by day, day by day, day by day. Maybe you want to achieve the target. You may take probably 6 months or 1 year or 2 years depending on the girl itself. Yeah. So now coming back to quasi-static and quasi-equilibrium processes. So if you have a compressor, if you have a piston here, you press the piston slowly, little by little, little by little. You're slowly increasing the pressure. But because it's so slow, what happens? Even the increase of the pressure can't be felt. You get it or not? So this wall will not rupture. Okay? The temperature will just not rise and spike and cause some changes inside these molecules here. Okay? You get it or not? Yeah? Slowly, little by little. So for this process to say, it depending how long, the case. It's actually, it varies case to case. So it's very difficult. Like you approaching a girl, sometimes 6 months, sometimes 1 year. Yeah, as long as it's slow and steady. Okay, got it? So that is quasi-static equilibrium. Please do memorize. Do not write the example of you, approaching your girlfriend and giving flower, and don't explain that when I ask you that question in the exam. Okay, make sure you put it in technical term, which is when a process proceeds in such manner that it remains infinitesimally close to the equilibrium state at all times. Okay, now coming back to the next, proceeding forward to the next part of the lecture. So let's see this state. Can you remember state 1, state 2, final state? Yeah. So and then example I gave you. This is your house. This is Sunway, right? This is the process path. So process path can have more than one. Yeah. You can also take Federal Highway and reach your house, or you can take the Kasas and reach your house, or maybe you want to take NPE, another alternative route, and reach your house. It depends. As long as you reach your final state. Yeah. Different route will have different calculation. Okay. You will see that in the next class. Yeah. Yeah. Different route will cause you different, like toll charges, petrol charges, and all this thing, right? Okay. So something like that. Okay. Now coming back to this, ISO. This is a term that maybe you have seen, isothermal in your chemistry. Yeah. Isothermal means temperature is constant, whereas isobaric is pressure is constant. Isochoric is when the volume is constant. Yeah. What is a cycle? A process during which initial and final state are identical. So cycle means you go and then you come back. You go and then you come back, like you go to Sunway University and then you come back to your house, right? It's a cycle. Yeah, it's a cycle. Okay. So what is a steady flow process? Steady flow means no change with time. So if you on a tap, your nozzle in your garden, okay, you want to wash your car. So if let's say the water is actually flowing 3 liters per minute, it is 3 liters per minute. That's called a steady flow. Not, real life, of course, your Shabas water for a while 3 liters, and then it will be maybe 2.9 and then maybe 2.7, fluctuating a bit, right? 3.2 and then 3.1. But then in your textbook, when you talk about steady flow, if 3, it is 3 constant. Okay, so this is called steady flow. Okay, anything that's opposite it is unsteady, or you have another word which is transient. So steady flow is emphasized during this lecture. Yeah, we will be looking at equipments like turbines, pumps, boilers, condensers, heat exchangers, power plants and refrigeration system in chapter 5. Okay, so just for the time being for this chapter, you just need to know what is the meaning of steady flow. Okay, so we have ended this second video of chapter 1. And if you see, the video actually covers only theoretical part. Yeah, chapter 1 is basically what you call theoretical. You need to memorize. Not much of questions is coming out. Actually, no questions comes out from chapter 1 in the final exam. But then you need to understand and memorize the terms. That is the most important. That will be tested in chapter 2, 3 and onwards. Okay, so with that, I'll meet you in the next video, which is the third video for chapter 1. Thank you.